Hey guys, uh, in this video we'll be talking about equilibrium or just balancing simply. So earlier we have talked about balancing when, let's say, this was the object and this was a force being applied to it of, let's say, 10 newtons, and there was a force in the opposite direction of the same magnitude, let's say 10 newtons. Call it F2, this is F1. So when F2 is equals to F1 in magnitude and they're both in opposite directions, we say that the net force becomes 0, and the object, because of the since the net force is 0 and the formula says F is equals to ma, so acceleration becomes 0, and so the object does not translate or does not move in any direction. However, this is the first condition of equilibrium, and the first condition says that net force should be 0. However, there is a second condition, and I'll tell you why I'm telling you during this chapter. The second condition says net moment or net turning effect should also be 0. So a force, according to the first rule, should not be translating an object. A force should not be translating an object, translating, or according to the second one, it should not be rotating an object. So we'll have to stop both of them from happening. So we'll see the complicated problems where both of these things are there, but for now we'll see how we can cause the net moment to be 0. So let's see a situation here. Let's talk about a plank here, wood, and let's say this is the 50th mark, and I am applying a force on this plank, say 100 newtons, and the scale is in centimeters. Let's see the moment of this force. Moment is simply F times perpendicular distance, which is this distance, which is 50 centimeters. Since this is, let's say this is the 100th mark, so 100 minus 50, this distance is 50 centimeters or 0.5 meters. So the moment of this force will simply be 100 times 0.5, which is 50 newtons meter. So this plank would be moving in this direction, in the clockwise direction, with a moment of 50 newtons meter. However, to stop it from moving, I will have to apply, my goal is to apply a moment of 50 newtons meter anti-clockwise. So what I will do, I can simply just apply 100 Newton force here at the 0 mark. Because of this force is moving in this direction with a moment of 50 newtons meter. This force, let's find out the let's find out the moment of this force. Simply be F times d, which is 100 again times this distance is again from the pivot. This distance is again 0.5 meters. This is the pivot. So 100 times 0.5, so 50 newtons meter. but this time in the anti-clockwise direction. So in this case, this anti-clockwise 50 Newton meter would balance this clockwise 50 Newton meter. And we can say that moment clockwise equals moment anti-clockwise. And this is a condition for moments to be balanced. So we can say, since this is happening, the clockwise moment is equal to the anti-clockwise moment. So we can say that this is balanced in this case. Let's see one more situation here. So this is the same plank. Now this is the 50 mark and this is the 100 mark. Now I'm applying a force here of 100 newtons here. We know the moment, how to find the moment of this force. Because there is a perpendicular distance, there exists a moment. So this is 0.5 meters. So moment of this one force, which would take it here, the clockwise force, let's say clockwise, would be 100 times 0.5. So moment clockwise would be 50 newtons meter. Now let's say I am not applying a force here. However, instead what I do is I apply a force here of 100 newtons. Let's see the moment. Because it's being applied here, just assume that this is the pivot. So you can imagine this would make it move here. This is an anti-clockwise moment. So anti-clockwise moment for this force would give me 100 times the perpendicular distance, which is 0.2 meters. This would give me 20 Newton meter. So here we have a clockwise moment of 50 Newton meter in this direction. However, to stop this moment, we have only 20 Newton meter. So since the clockwise moment is not equal to the anti-clockwise moment, this is not a balanced situation. However, if I add one more force on this mark, 20, let's say 100 Newton on this 20 mark, so this would again be an anti-clockwise force. So it would be taking it here, the anti-clockwise direction. And for this anti-clockwise moment, this force, the moment would be 100 times 0.3. This would become a 30 Newton meter. So we can see that the anti-clockwise moment, the sum of anti-clockwise moment is 30 plus 20. Total moment in the anti-clockwise direction is 50 newtons meter, and the total moment in the clockwise direction is again 50 newton meter. In this case, this bar would not rotate, since the sum of anti-clockwise moment equals sum of clockwise moment. So this is the condition, that the sum of the anti-clockwise moment should be equal to the sum of the clockwise moment. Now let's see some more examples of this same thing. First of all, remember, sum of anti-clockwise moment should be equal to sum of clockwise moment. This is called the principle of moments. This entire thing is known as principle of moments. And this is a defining principle of equilibrium or balance situation. Now let's see. the question says, let's see, this is the pivot again at 50. It's fixed here. The question says that I am applying a force of 500 newtons, let's say at the 60 mark. It doesn't look like 60 here, but I'm just taking it 60. So at the 60 mark, this is a centimeter scale, I'm applying a 500 newton force. The question tells you that this scale or this plank is in equilibrium. And it also tells you that at the 20 mark, there is a force being applied to balance this turning effect. Now, they're asking you to find out this force that can balance this moment if it's applied at the 20th mark. So let's find out the moment caused by this force. Simply, this would be the clockwise moment, so we write MCL. This would give me force times distance, which is equals to 500 times, this is 0.1 meters. This is 50 Newton meter. Now this is the clockwise moment. This is clockwise. So what I have to do, I have to find out the force which multiplies with this distance and gives me this answer, because then they would be balanced, and if it's in equilibrium, this is our condition. So what I will do, I would simply write F times D is equals to 50, because this is what I want to achieve in the anti-clockwise direction. So F is unknown times D, this is 30 centimeters, which is 0.3, is equals to 50. Now you can calculate F is equals to 50 divided by 0.3, and this would be 500 divided by, so this would give you 167 point something like this, 167.7 newtons. So a force of 167.7 newtons at a distance of 30 centimeters from the pivot would give you an exact value same as that of a force of 500 newtons that is applied on the 60th mark. And because of this, if you just multiply it again, you will get a 50 Newton meter in the anti-clockwise direction. The sum of anti-clockwise moment would be equal to the sum of the clockwise moment, and so it would be in equilibrium. So this is the condition of equilibrium, and we will see how these conditions help us in our daily life situations. So I'll see you guys in the next video. Stay tuned to it.